Hello students, in this video I'll explain Kent Ridge Prelim paper 2 for the year 2018. Okay, so we'll go through how to get the answers, okay, and some of the recommended answers as well. Okay, so for those who have missed out question 1 in the previous lesson, basically, okay, you need to read through the question itself. Okay, and you'll find that there are a few things that is very important. First of all is the solar panel. Second, there is wires that is actually linked to the electric motor. And last but not least, you notice that the well, which is where the electric motor and the water pump is going to pump the water back up into the water trough here. So there is a difference in height as well. Okay, so knowing all this, we know that the solar panel actually converts light energy from the sun into electrical energy. That's why there's an electric cable here. Okay, but some of you are actually very confused about why is there this electric motor. Well, the electric motor is here to basically pump the water up the water pipe, okay, and into the water trough. So in doing so, it's actually changing electrical energy into movement energy or kinetic energy. So once it moves the motor inside, the kinetic energy will actually be converted into gravitational potential energy again, which will push the water up the pipe. Okay, as the water goes up the pipe, it will be changed into gravitational potential energy and eventually lands up in the water trough. Okay, so the answers are as follow. Okay, part 1, okay, which is solar panel. Solar panel changes the light energy into electrical energy. Part 2, the electric motor. Okay, so the electric motor will change the electrical energy into kinetic energy. And last but not least, when it travels up the pipe, okay, this kinetic energy of the water, okay, will also be changed into gravitational potential energy. So for all these, please make sure you check your spelling, okay, as the spelling is already given. Okay, next up, okay, for this part B question, okay, you must remember that power is actually energy divided by time. Okay, so having said that, when we say energy divided by time, you read through the question itself. Okay, you notice that the energy is already given as 600 joules. Okay, and the time given, okay, is 2 minutes to pump this 10 kg of water. So you have to take note that time here must be in seconds, while the energy here must be in joules. So these are the two important things that is required. Okay, so after doing the correct conversion, you'll be able to get 5.0 watts. Okay, question 2. Okay, this one, please go and remember the 7 components of the electromagnetic spectrum. Okay, basically it's radio waves, microwaves, infrared radiation, visible light, ultraviolet, X-rays, gamma rays. Okay, for those who have forgotten, please make sure you revisit the song, okay, the electromagnetic spectrum song, which will help you to remember a little bit. Okay, so next part B. Okay, they ask for the electromagnetic spectrum or electromagnetic wave that has the shortest wavelength. The answer is actually gamma rays. Okay, some of you might be a bit confused about how we actually get this answer. One way is just to memorize. Okay, there is a second way. Okay, a second way which requires a little bit of understanding. Okay, so I'm going to explain to you here. First off, you must understand that all okay, I shall write in short form, all EM waves travel at the same speed. Okay, so this one you must first understand, and the speed that we are talking about is 3.0 times 10 to the power 8 meters per second. Okay, all these EM waves, all the 7 components of EM waves travel at the speed of light. Okay, so second thing is there is a relationship between the waves, the speed, and the frequency as well as the wavelength. Okay, so to help you to remember, okay, I shall put as the wavelength here. Okay, wavelength, frequency, okay, long to short, okay, low to high. Okay, so there is this opposite relationship between wavelength and frequency for all the wavelengths, for all the EM waves. Okay, so for let's talk about the extreme first. Okay, a long wavelength and a low frequency, we are actually referring to radio waves. Okay, radio waves have one of the longest wavelength and the lowest frequency. On the other hand, gamma rays, okay, on the opposite end, gamma rays has the shortest wavelength and the highest frequency. So this is, why do we get this? Because these two, okay, relationships actually comes from this same speed for all the electromagnetic waves. Okay, so if you look back at the question itself, okay, you notice that in this question, they use frequency as a representation at the bottom. Okay, so if you go back to this, okay, the frequency is a representation here. Okay, gamma rays will have the highest frequency, which is shown inside your question. But at the same time, gamma rays will also have the shortest wavelength. Okay, and that's how we actually got to this answer itself. Okay, so next up, the explanation wise is actually because it has a high frequency, you do not need to know how to do the calculation from there. Okay, so these users of the electromagnetic waves, please go and remember, okay, all of them. Okay, at least one example for each of the electromagnetic waves. Okay, you should be able to sort out all these by yourself. Okay, next one, part D, describe how high levels of microwave energy can be dangerous to people. Okay, so this is a common, how to say, a common knowledge, okay, for all. Okay, basically when we have high levels of microwave energy, okay, these microwave will actually damage the human cells. Okay, so which will lead to cancer as one of the possible outcomes. Okay, or you can think about the possibility of heating up your cells itself. Okay, so think about the microwave that you use to cook the food or heat up the food in the microwave oven. Okay, so the microwave oven uses microwave to heat up food. So how does it work? The microwave actually has the same frequency, okay, as the water. So basically you excite, okay, the water molecules and causing it to heat up. Okay, and that's how it actually cooks the food. So imagine now you put a human hand inside the microwave, and the same concept will apply because the human hand has water. Okay, and the water will excite, okay, and causing it to be heat up, and therefore causing it to be damaged. Okay, another way of saying it is also it can lead to other forms of cancer and mutation along the way. Okay, but it is actually more preferred, okay, the answer given here is actually more preferred to have heated cells or damaged cells. Okay, next up, question 3. Okay, question 3, for A part 1, okay, they actually ask you to calculate the time taken in seconds. Okay, you notice I do this calculation over here, okay, as a very simple subtraction. Okay, so please check your subtraction very carefully. Okay, and you should be able to derive to 2 minutes and 40 seconds. Okay, so these 2 minutes and 40 seconds, please go and convert it into seconds because that's what the question wants. So remember, every 1 minute is 60 seconds. So 2 minutes is 120 seconds, which will give us 160 seconds. Okay. Now, this marking scheme that is given by the school also indicates that if you did not convert 2 minutes into seconds, okay, you will actually be penalized. Okay, for part 2, okay, they want average speed. So average speed is just total distance divided by total time. So they are given you 5,000 meters. Okay, so you substitute in, you should be able to get 31.3 meters per second. So make sure you change into 3 SF. So this is important. Okay, next up. Okay, using information on the clocks, compare the average speed of the car between cameras A and B and between B and C. Okay, so they would like us to go to compare the clocks, okay, and find out the time difference. Okay, we know that the distance between camera A and camera B, as well as camera B to camera C, is always 5,000 meters. Okay, based on the part 2. Okay, based on this part, 5,000 meters. Okay, so now the problem is the time. So from here, camera A to camera B, okay, the time taken to complete this part is actually 2 minutes and 40 seconds. Okay, on the other hand, okay, the last part over here, okay, it took the fella 8 minutes, I think, 8 minutes plus to complete. How do I get from to 8 minutes plus? Okay, same thing, you need to do this calculation again. Okay, but there's also this possibility of using your calculator. So I'm going to demonstrate to you how do we actually use it. Okay, so for the Casio calculator, look for this. Okay, 0, comma, comma, comma. Okay, so first off, okay, I'll key in the larger timing. Okay, so it's 8 hours, 54 minutes, 20 seconds. Okay, so 8, this, 54, this button, 20, this button. Okay, minus 8, 45, 57. Okay, once you are done, press the equal sign. Okay, you get 8 minutes and 23 seconds. Okay, you have to understand that this is actually what they call the degree, minute, seconds, okay, function. Okay, so this degree, minute, seconds function have the same relationship as the hours, minute, and seconds. That's why we can apply over here. Okay, so anyway, you notice that in the last part between B and C, the person took 8 minutes 23 seconds to complete this 5,000 meters. On the other hand, okay, between A and B, okay, he only took 2 minutes and 40 seconds. So what does this mean for us? Okay, so this actually means that we will have a slower or smaller average speed, okay, between B and C, okay, as compared to A and B. So if you look at my answer over here, okay, take note, this is the answer that I worked out. Okay, I did not, okay, refer to the answer scheme when I do it. So the answer here would be actually like what you will be writing. Okay, so basically, okay, he will have slower, he will be traveling slower between BC, okay, as compared to AB. Okay, so as what we have mentioned just now over here. Okay, next up. Okay, part B, they are asking you whether this whole journey, okay, the whole journey from A to C, okay, whether this car has reached the speed limit, okay, of 30 meters per second. Okay, so for this particular question, actually it will be easier to work from the second part, the explanation part, before giving the answer for the estimate part. Okay, so the total time taken from A to C is 663 seconds. How do I arrive at this? Okay, basically, if you look back at the first part, the part 3, A part 3 question, you'll be able to work out this 8 minutes 23 seconds already. Okay, so from here, okay, you just need to add with 2 minutes 40 seconds, okay, and calculate in terms of seconds. So from there, you should be able to get 663 seconds. Okay, then do your calculation for the average speed, okay, which is actually 5,000 times 2 here. Why 5,000 times 2? Okay, because it's the distance between A to C. A to B is 5,000, B to C is 5,000, so 5,000 times 2. Okay, so once you have done that, okay, you should be able to reach 15.08 meters per second. Okay, so you notice that this is actually slower or lower than the speed limit that is given of 30 meters per second. Okay, hence the average speed is actually lower than the speed limit. Okay, question 4. Okay, question 4 part A is very straightforward. Okay, you just need to draw a simple circuit diagram with a switch and a light bulb or a lamp. Okay, so take note, you must have the switch. Without the switch, you will be totally penalized here. Okay, so this must be in series as well. Okay, if it's in parallel, then you have a short circuit. Okay, part B. Okay, part B, you need to know that for series circuit, okay, so something for you to take note, for series circuit, the total resistance, you just need to add them up together. Okay, so I'll jot this down for you over here as one of your notes. Okay, total resistance of a series circuit, okay, is equals to R1 plus R2 plus R3, okay, plus so on and so forth. So basically, if I have resistors connected in series, okay, in order to find the total resistance, I will just add them up together. Okay, so this one you need to know. Okay, but the calculation for the total resistance of a parallel circuit, you do not need to know. Okay, because this one is simple concept, so you should know. Okay, so going back to the question itself, okay, since the first part they say the two lamps are connected in series, okay, take note, in series, so you just add them up together, you should get 12 ohms. Okay, part 2, B part 2, they are asking for the benefits or the advantage of connecting in parallel. Okay, so this is one of the best answers that probably you can think out of as well. Okay, when you have a parallel circuit, okay, let me draw a very simple parallel circuit over here. Okay, something that looks like this. Okay, in a parallel circuit such as this, if one of the lamps is not working, the other lamp can continue to work because it's still a closed loop. Okay, so this is the benefit of the parallel circuit. Okay, part C. The hazard that is shown here is actually damaged insulation. Okay, you can see the wires sticking out over here with the rubber insulation almost removed totally. Okay, so what's the explanation over here? Okay, basically the wire, okay, why is it a hazard? Okay, the wire over here that is exposed, okay, when a user such as me, if I accidentally touch it, I'll get electrocuted or receive an electric shock. Okay, so you just need to write either electrocution or electric shock as the answer. Okay, but you must say the user must touch it. Okay, without saying that, it's very hard to understand how the person will actually get electrocution or electric shock. Okay, so bear in mind that electrocution leads to death. Okay, electric shock just gives you a shock. Okay, so electrocution is more damaging than electric shock. Okay, next up. For question 5, okay, this particular question, okay, there are a few things you need to take note, okay, because you need to refer to the numbers that is given in the table. Okay, so after you refer the numbers given in the table, you must first give a correct scale, okay, reasonable correct scale, okay, for your x-axis and your y-axis. Okay, so it must be evenly spaced out, okay, and labeled clearly. Okay, second thing you need to take note is the crossing out of the points or marking out of the points. Please mark it out clearly. Okay, and last but not least, okay, if you've done everything correctly, okay, you have to do a best fit line. Okay, so best fit line actually does not mean that you must pass through all the points, not all the lines, sorry, all the points. Okay, it does not mean that. Yeah, so you have to understand that. Secondly, okay, you have to check very carefully using a ruler if it happens that all the points will lie on a straight line, join them up together. But if, like my case, somehow I didn't get that, then I will have to draw my best fit line, which is two conditions. First condition, roughly the same number of points above and below the line. So if you can see very closely down here, this first point here is above, well, this point is slightly below. Okay, second, okay, you do not need to pass through all the points. Okay, the distance between all the points should be as small as possible. Okay, so those are two general guidelines. Okay, but don't worry, for the normal tech syllabus or for the normal tech expectations, most of your answers or most of the graph that is given will or should, okay, give you a very nice best fit line. Okay, so having answered part A, okay, and one more thing, because of the need for me to present on a video for you, okay, that's why I draw all my answers, or I label all my answers in blue. Okay, but for you, because you're submitting your work to SEAB for marking, okay, you actually need to draw all graphs in pencil. Okay, so do take note of that. Okay, part B. Okay, describe how the rate of photosynthesis varies with the concentration of carbon dioxide. Okay, so what you need to do is basically refer back to the previous part as well. Okay, and you notice that as the concentration of carbon dioxide increases, okay, as this part become bigger, 100, 200, 300, 400, you notice that the rate of photosynthesis also increases. Okay, so that's why you have to write in this way. Okay, as the concentration of carbon dioxide increases, the rate of photosynthesis also increases. Okay, next up, explain one way in which the use of fertilizers helps to increase the food production. Okay, this way is actually from recall of your knowledge from the textbook. Okay, you have to understand that fertilizers does a lot of things for us. Okay, this is one thing that is that it does for us. Basically, if the soil quality is poor, it lacks nutrients. Okay, the fertilizers that you put in will actually supply the nutrients and minerals that is required. Okay, so there is a whole other list of information. Okay, so these are a few of them. Okay, so you can actually also provide the magnesium for chlorophyll formation, increase the, most of you I think would write this down. Okay, there's an increase of faster growth rate, okay, of photosynthesis if there is more fertilizer. Okay, as well as the because there's added nutrients around, okay, the crops will be able to grow more healthily, and therefore they are able to produce larger, heavier crops, okay, per unit area. Okay, next up, part D. Okay, you notice these parts. Okay, this factory that produces fertilizers, okay, located next to a small river. Okay, this, because it produces fertilizer, this is first keyword. Okay, and next up is after they wash the machinery, okay, which produce this fertilizer, they'll actually release it into the river. Okay, so from our chapter, this particular chapter that they are referring to, we know that when we release this contaminated water that is full of fertilizers, and also at the same time it will contain lots of phosphates. Okay, so when we release this into the river or water body, okay, it will actually lead to algae bloom. So what does algae bloom do to the river or to the aquatic animals? Okay, so quick revision over here. If this is the river, okay, I use blue for the water. Okay, so basically the contaminated river, okay, will cause an algae bloom. So what does the algae bloom do? Basically the algae will start to block out the sunlight. So your light rays, your sunlight, okay, cannot get through to the bottom. Okay, so this causes the plants at the bottom. Okay, your plants, okay, remember there are aquatic plants in the water. Yeah, your plants in water will die or will not be able to photosynthesize. Okay, so simple plants, huh? Yeah, so these plants cannot photosynthesis. Okay, they cannot perform photosynthesis, okay, due to lack of sunlight. Okay, so you have to remember this. Okay, why? Because we know that photosynthesis produces oxygen. So if there is lack of sunlight, the plants cannot perform photosynthesis, which means the oxygen in the water is not replenished, is not returned. Okay, so there is no additional oxygen. So the amount of oxygen in the water will slowly decrease. Okay, so after it slowly decrease, what will happen? The plants will die. The animals living in the water will also die due to the lack of oxygen. Okay, basically this is what this refers to. Okay, next. Okay, this one very simple. You need to know the separation techniques very well. Okay, some of you might, like me, I almost got confused between these two. Okay, you have to look very carefully. Why? Because this distillation and evaporation, they are actually quite similar. Okay, so a few key ideas, okay, that you need to remember is that distillation, okay, you actually get water, get liquids. Okay, the objective of distillation is to get the liquids. Okay, for evaporation, okay, the objective is actually to get the soluble solid. Okay, so these two, you please remember, these are the key ideas that you need to remember. Okay, okay, next up. Okay, this one quite a long passage, okay, but if you read very carefully, down here at the first part, sodium hydroxide carbonate is slightly alkaline. Okay, so this is a keyword, alkaline. So we know that alkaline means yes, pH higher than 7. Okay, but if it's slightly, so out of the answers here, if it's slightly above pH 7, that means pH 8 would be the best answer. Okay, next, do you want to complete the word equation? Okay, so for the word equation, basically if you have acid plus carbonate, you actually get carbon dioxide, salt, and water. So this one you should know. Okay, please memorize the word equations. Okay, next, part 3. This one is actually an application of knowledge. Okay, in fact, it's a daily knowledge. So if you look at the situation here, without the baking powder, this bread is actually quite small. Comparatively, the bread that has the baking powder will actually be bigger. So what happened? Okay, how come the bread become bigger? Okay, so basically, if you read the parts above here, baking powder contains sodium, hydrogen, carbonate, and crystals of uric acid. So you have acid, you have a carbonate. When water is added, acid reacts with the sodium hydrogen carbonate. So these two will react, which should be this reaction. This reaction takes place in the dough when water is present, which means down here, we know that when we make bread, you need to add water. So what happens after that? So this carbon dioxide that is produced, okay, will actually be trapped inside the dough. So when it's trapped inside the dough and more of the carbon dioxide is produced, your dough will actually become bigger and bigger. Okay, so this causes the bread to rise and expand. Okay, so that's why your bread actually becomes bigger. Okay, so what is the evidence of such a thing? Go to your bread, go and find a slice of bread and look at the surface of bread. You notice that there is a lot of holes, okay, on the surface of the bread after you sliced it, okay, the center portion, okay, especially this type. Okay, so these are evidence that there's actually gas trapped inside the bread that causes it to expand. Okay, and this is actually the cause of causing the bread to become bigger. Okay, next, define balanced diet. This one you need to know. Okay, basically a balanced diet is just a diet that has the required nutrients for a person, okay, in the correct amounts. Okay, it is not it does not mean everything is equal. Okay, for example, you cannot have the same amount of fats as carbon dioxide for a diet, for a balanced diet. Okay, so that doesn't make sense, because if you have too much fat, we know that if a person have too much fat, you will actually suffer from some health problems. Okay, next up, water is important to life. What is the condition for the deficiency? Deficiency, for those who do not understand, okay, deficiency means lack of. Okay, this is the meaning of lack of. So if there's a lack of water in the body, it's actually called dehydration. Okay, so next, okay, this one is just an application of your daily knowledge. You can actually name any person, okay, that perspires a lot as the answer. Okay, so you can even say people who live in deserts and stuff. Okay, why? Because they actually perspire a lot. Perspire, in our layman term, we actually call it sweat. Okay, but sweat is actually not a good term to use. Okay, because in the English dictionary, sweat refers to animals. Okay, while on the other hand, perspire refers to human beings. Okay, so the general idea is they perspire a lot, and because they perspire a lot, they actually need to take in lots of water to replace it. Okay, so this is general idea. So why do we even sweat or perspire a lot? Why do we even perspire a lot? You have to remember that when we perspire, we are actually trying to cool down. Okay, so this helps our body regulate our temperature. Okay, so next up, name two foods that have a high water content. You just need to name two different food. Okay, meaning what am I trying to say here? You cannot say watermelon and honeydew, for example. Okay, you have to name two different categories of food. Okay, so in general, you can even write fruits and vegetable. Okay, they contain high amounts of water. Okay, you can even say drinks as well as part of the answer. Okay, so you can name the fruits, for example, the what, orange, watermelon and stuff. Okay, and name the vegetable if you need to. Okay, part C, part 1. Why do we need to heat up the yogurt to 85 degrees Celsius before adding the bacteria? Basically, when we take the milk in the first place, it contains a lot of microbes. Okay, microbes here refer to anything that is too small for the human eyes to see. Okay, so it can be bacteria, it can be virus, it can be yeast, okay, fungus and all that. So by raising the temperature to 85 degrees Celsius, it will kill off most of the microbes that will probably affect the quality of the milk. Okay. So after that, why do we need to cool down before adding the bacteria? Same idea as before. If you heat up to 85 degrees Celsius, the objective was to kill the microorganisms there. Okay, and bacteria is a microorganism. So if you put the bacteria into the milk when it's 85 degrees Celsius, basically your bacteria is going to die. Okay, it's going to be destroyed. Okay, so that's why we have to cool it down before we add the bacteria in. Okay, so it doesn't die. Okay, in the next part, part 3, which one is best to avoid coronary heart disease? If you do not know what is coronary, it's okay. You just know that you just need to identify heart disease. Okay, heart disease is related to a lot of things. Okay, salt is one of them. Fat is another. Okay, so salt and fat. Okay, a diet high in salt and fat will lead to heart diseases. Okay, any type of heart diseases. Okay, so basically you need to find this yogurt that is low in fat for part 3. Okay, and you notice that for fat, okay, yogurt C is 4.2, yogurt D is 0.2, so which means yogurt D is a better of the two. Okay, so because it has a lower amount of fat. Okay, part 4, if you want to build strong bones means you require calcium. Okay, so which of the yogurt has higher calcium is very obvious. This yogurt D again has higher calcium, therefore is the answer. Okay. Okay, question 8, very straightforward. Okay, if you know your parts of the digestive system very well, you will be able to get all the answers here very easily. Okay, so for K, it's actually the esophagus or the gullet. L is the stomach. M is the pancreas. N is the small intestine. P is the large intestine. R is actually the rectum. So be very careful, rectum. Okay, and if we point to the hole at the bottom, then that's the anus. Okay, anus is where the feces come out. Rectum is where we keep the feces. Okay, so pancreas is M, stomach is L. Okay, for this particular question, you need to interpret the diagram very, very carefully. Okay, so if you look very carefully, down here is talking about time taken to digest the starch. Meaning, if I look at 10, this one means it's 10 minutes to digest the starch over here and here. Okay, on the other hand, down here is about 1 minute, I think. Okay, at this point is 1 minute to digest the starch. And if you look very carefully, this lowest point is around 7.5. Okay, so at which pH does the enzyme in saliva work the fastest? Fastest here refers to shortest time. Okay, and which one is the shortest time? It's actually at this point, the lowest point of the whole curve. Okay, and this is actually pH 7.5. Please write pH as the unit here. Okay. How long does it take for the starch to digest at pH 6? So if you look at 6 again, where is pH 6? pH 6 is here. Use your ruler. Okay, and go up, you're able to see that it actually hits 4 minutes here exactly. Okay, so that's your answer, 4 minutes. Okay, use your ruler please. Part 3. Okay, the stomach produces hydrochloric acid. Use this graph to suggest why the enzyme found in the saliva does not work inside the stomach. A very repetitive question. You notice that in this particular graph, okay, the lower pH will result in a larger amount of time, and down here you notice that at 4 minutes is almost the maximum. Okay, there's no more data after that. Okay, so for the stomach, because the stomach has a lot of hydrochloric acid, it is actually very acidic conditions. In fact, hydrochloric acid is known to have a pH of about 2 and below. Okay, so the enzyme basically does not work well in the low pH conditions. Okay, so what will happen to the enzyme? It will be destroyed. Okay, it will be denatured. Okay, and basically it only works best at the pH 7.5. Okay, name one other factor that can affect the enzyme activity. The other known factor that we know of inside the syllabus is actually temperature. Okay, last but not least, this one is showing a diagram of the route taken by the blood around the body. Okay, please be very careful. Over here, you see the lungs, you see the body, but you see blood vessel, but you don't see any other information. Okay, so this very squarish thing at the center here, it actually represents the heart. Okay, so what is the heart? Basically, the heart is just a muscular organ. It's a very important organ, okay, that pumps blood to the other parts of the body. Okay, so very simple question. How do we get the 2 marks? Actually, the first part, muscular organ, will give you the 1 mark, and the function of the heart will give you the 2nd mark. Okay, please be very, very careful. Yeah. Okay. Next up, they ask for what type of blood vessel is blood vessel A. So if you refer back to the diagram, blood vessel A actually carries the blood from the body to the squarish thing in the center, which we now know is the heart. Okay, so when you carry the blood from the body, other parts of body, to the heart, okay, this particular vessel is actually the vein. Okay, so one of the most important structural or structures in the vein itself is that it contains valves, valves. Okay, so the valves will prevent backflow of the blood. So for those who have forgotten about the valves in the vein, basically we have valves like this. So what is the valves? This is the valves. Okay, it's like a gate, okay, to prevent the blood from flowing backwards. Okay, so how do we know whether which direction should the blood be flowing in this case? Basically, you see this like the arrow. Basically, the blood will have to flow this direction. Okay, blood flow. Okay, so this gate itself actually will close when the heart stop pumping, okay, during the interchange of the pumps, okay, and when the heart start to pump again, you draw the blood upwards in this case, and you open the valve here so that the more blood can flow through. Okay, so the direction of the valves actually does tell us where the blood will flow. Okay, so next, name the difference between A and B. Blood vessel A and B. What's the blood inside? What's the difference inside? Basically, if you look back at the diagram, you notice that blood vessel B carries blood from the lungs to the heart again and to the body. So this means that this is actually the oxygenated blood, because blood from the lungs is rich in oxygen. On the other hand, for this next part here, the body has definitely going to use the blood, use oxygen in the blood, and from there it will be pumped into the heart itself. Okay, so when it does this, the deoxygenated blood will actually be flowing in blood vessel A. So what's the difference between the two? Blood vessel B will carry blood that is rich in oxygen. Okay, sorry, I missed out a few words. It's carrying blood that is rich in oxygen, but blood vessel A is actually carrying blood that is low in oxygen. So these are the answers for Cambridge Secondary School Prelim Examination 2018, Paper 2. Okay, so work hard for your other papers. Please try all the questions on your own. Do not give up. Okay, thank you.